Hi everyone, I'm Karl Paul. I'm a mid-sized content creator in the pro-nuclear space. I've been producing live YouTube shows for Esna.Earth with the benefit of Gabriel Ignetti's help and the support of wonderful people like you. Some of our best shows covered synthetic fuels with Dr. G.K. Shriya Prakash and a debunk of Netflix's 3 Mile Island with Lake Barrett. I almost left out this intro from my presentation because my behind-the-scenes activism is so much more consequential. 3 years ago, that's right, it has been 3 years since the last Thorium Energy Alliance conference in Oak Ridge. I'm happy to see you all, and I hope that everyone online enjoys the program. We've made it this far, we're growing and becoming stronger as an advocacy community, and today I'm happy to share with you my journey, my history, and the history of my organizations, our challenges and victories, and what you and I are going to achieve together. 3 years ago, I spoke to you from near my childhood home and delivered a vision for a big tent organization which would move the public towards supporting nuclear energy and other vital climate solutions. I'm excited to show you that there are hidden eco-modernist allies all around us, that we need to develop the consensus-building relationships, and we need to activate the rational and solutions-focused majority for humankind to survive and thrive in the future.
Well, hello, everyone, and welcome to Environmental Coffee House. I am Sandy Shallis, and welcome, Karl Paul. You got an introduction to Karl in the beginning here. Now, I have known Karl a long time, and I'm just going to tell you right now that this show is about what Karl is going to tell us, teach us, talk about. Not about me. And I expect everyone to be putting a cue in front of questions and at the end, and also be no rudeness because it's a very controversial topic. So welcome, Karl. Hi. And finally, after all this time, we are here.
Thanks. I'm really happy to be here. This is, of course, a very challenging topic for anyone who thinks that the environment is going to help, because I'm kind of telling you that, oh, there are solutions. And so it's difficult. It honestly is difficult to think that, okay, we had a solution. We had it decades ago. And if we just did it, we would be in a different world than we are today. But I can't take credit for being the only person to come up with this. And there are many people before me who have had this idea. I lean on a lot of different people in terms of the background, the things that I've learned, people that have gone into university thinking they were going to build fusion reactors, who then switched to nuclear fission reactors in order to, try to solve the climate crisis. And that person is my friend Nick Turan, who is also known as What is Nuclear? And you can find out more information about nuclear energy in general on his website, whatisnuclear.com.
Okay.
What I do, I'm Soyaddle on Twitch, also Your Environment Seattle on Twitch and YouTube. And I've done a number of different things, both locally and on an international stage as a nuclear advocate. And I know that you're interested in talking about fusion today, Sandy. So go ahead with any questions.
Well, we're going to talk about fusion, but we're going to talk about you first, Karl.
Awesome.
Because I also want to talk about some of the amazing things there's one thing that did not have to do with this, and that was when you were walking around Portland and you were filming the Black Lives Matters protests. And I was so impressed with the work you did there. It was amazing. You were definitely an activist there, and not a nuclear activist, but a pro human rights activist. You were
Right.
definitely for everyone that was there protesting for Black Lives Matters, and I loved it. And am I wrong about
Thank
that?
you.
I'm not wrong
No,
about
you're
that.
absolutely right. I've sort of built up my relationship with the Seattle Democratic Socialists of America since 2019. I was involved in the Sean Scott campaign. Unfortunately, he did not win, and we got a horrible NIMBY sort of veiled anti-transit city council member to
Ugh.
be in charge of transportation. So yeah, it's not the best, but but it's what we've got, and so I'm happy to work with anyone who is pro humanity, pro solutions. And unfortunately, that doesn't always include the Seattle DSA, but maybe I'll find time again to reach out. So yeah, in 2020, in April 2020, we shut down for COVID, and then later on, this horrible killing from the police brought the nation together. And I think that we started something very important, and unfortunately, it hasn't yet brought us to real justice, but maybe we can see it someday. And it just takes continuing to work towards justice in order to accomplish that. I'm really proud
Yes.
of the moments that I captured. I'm proud that I was able to share the real story behind the Capitol Hill occupied protest, and less
Yeah.
of the, the the scatological one America network view of what
Yeah.
was happening there.
Yeah, it's true.
And I'm definitely going to be there with my black mask and my camera. I'm going to be part of the silly film that they made to try and discredit the movement that happened there.
Well,
But
it was amazing,
yeah,
and I was riveted to your live streams the whole time. And of course, Portland wasn't destroyed. It wasn't a city that was completely
Mhm.
destroyed like the right wing
Yeah,
news outlets want to say. And you proved that, and you showed the
right.
community. So I know that
Yeah,
is giving a more human touch to who you are, because you know, my chat here, my channel has a much different viewpoint on the nuclear issue. And you are here to tell us today about why we should reconsider, or and talk about the fusion and the. I let Karl pick the title. And the title is very telling. And so we're going to go into a little bit about the title. We're going to go into about fusion, fission, and all of the things that you want to teach our channel's chat. And because this ain't about me, like I always say, everybody knows me ad nauseum. I say that all the time. So, Karl, welcome.
thanks.
And why don't you first start out with telling me about the title you chose and why you chose it? Because I let you run with it.
Right. Well, what the discovery we had this week was really significant. The National Ignition, National Ignition Forum, or the NIF lab, produced thermally net positive energy from a
Mm-hmm.
fusion reaction. And that's amazing. Why they did it, well, that's another story. The NIF is sponsored by an organization called the NNSA. That
Okay.
is the National Nuclear Security Administration. They do two things. They look for bad people getting a hold of nuclear materials, but they also maintain the United States arsenal of nuclear weapons. We have a great deal of invested in maintaining our nuclear arsenal, not just to maintain American power, but also so that we know if someone strikes at us, we can strike back, or we can exert our will on the planet, unfortunately. So this is the reality of being an advocate for nuclear energy, I have to know everything about this. And so I immediately knew that fusion ignition was not going to be a perfect gift to the environment.
Oh. Okay. So now that we know it's not the perfect gift, what kind of gift is it? Is it a gift?
It's a 1% return on energy invested. It's showing that fusion on Earth is possible, and it is possible to eventually be energy net positive. We need a extreme improvement in the efficiencies of every component involved in order to turn this from a successful experiment into a successful power plant. When our Department of Energy's Jennifer Granholm said that we would have fusion plants in the next 10 years, I found that really hard to swallow. And I don't think that that's going to be possible, unfortunately. I don't think that we've gone from 30 years away to 10 years away. Maybe we actually are 30 years away from a fusion plant now, but it's going to be very, very challenging to get there.
Well, I agree with that. And my next question, and again, it's not about what I agree with or not agree with, but what my next question then is going to be on the weapons war. What is our State Department really doing? Should we be skeptical? Because, the United States government doesn't have the best reputation for telling us the truth. So why don't you take a gander at that one?
Yeah, well, essentially, we have been dealing with an idle stockpile of nuclear weapons that has been untested since we passed something called the Comprehensive Test Ban Treaty.
Mm-hmm.
Instead of blowing up things underground, the United States took all the data we had, all the physics we had, and we're putting it into a supercomputer. And what that means is we're pretty sure that the devices, the substances we have, they're going to work just fine. Maybe a little bit less efficient over time, but they will keep working. We don't have the capability of using advanced simulations in order to really break ground in terms of the efficiencies, the yield, the miniaturization. Our physical testing ended decades ago. But with fusion ignition, we now have experimental evidence once again returning to the NNSA. And that means that we will have experimental micro scale results that give our weapons industry a new shot at developing new products, making sure that our existing products deliver what it was expected. And that's not good news for people trying to push back against the present hegemony of the world. Is we're talking about billionaires running the world, running America, and giving more power to them is not always a good thing for the people.
No. So basically, your viewpoints are very much progressive, with the exception of the nuclear power issue, the nuclear fission issue. And because but then I don't know. Maybe I am not around enough. Maybe I don't know. So who's talking about this in a positive way?
Of course, the Biden administration is very, very eager to describe this as a positive thing. It is, they're literally saying that we'll have nuclear fusion plants in 10 years.
Oh boy.
And it is sort of overselling the experimental and the pure science results and kind of keeping the NNSA, the atomic weapons angle, below the fold. And I think they've largely been successful in doing that. It's been a trying period with the war in Ukraine, and this could be adding a little bit of fire to that if it were not handled properly. So on one hand, it's good to accentuate the pure experimental results, But on the other hand, a lot of us see what's really happening, and that is further perpetuation of the military-industrial complex.
Oh, yes. That does seem like something that resonates with all of us. Absolutely. However, it seems to me in a way that seems like a little bit of a what is the word? The oxymoron or not. It doesn't fit that you would bring that you would be a pro nuclear energy person and then be a progressive. However, there are a lot of scientists that are, I guess, on the desperate end because of what we know that's happening to the Arctic and Pakistan this year. So tell me, how do you think, if fusion is not the thing, and you're telling us it isn't, how is nuclear fission, nuclear energy going to save us? And really, why do you think anything's going to save us?
Well, it could be too late. But the only thing that we can do is try. And so you can either try on your own. I was recently speaking to another degrowth guest, and his name was Mike Strass. Has a great blog. And so if you check out the Eco-Modernist channel, you'll be able to see our discussion with Mike, where we're talking about energy efficiency. We're talking about mass transit, riding electric bicycles, and really doing everything possible to reduce humankind's impact on the world. And the only disagreement we really had with Mike was he thinks we're just not going to have as many people in the future. And his solution is as many people as want to survive will learn to survive on their own. They will learn to practice regenerative agriculture and grow their own food and stop using energy, stop using the grid, disconnect entirely, sell your car, stop working, work 1 day a week. This is Mike's idea for disengaging from the capitalist system that has brought destruction to the planet. I'm not sure that I'm ready to do that yet. And so I'm still trying. I still think that, yes, we can get abundant energy from nuclear power. We can feed the world with fertilizer created not from fossil fuels, but from nuclear heat. That's the Haber-Bosch process that creates the nitrogen that's needed in all crops. You can either create it using nitrogen fixing plants or GMO bacteria that produces nitrogen, or many other little techniques that take a lot longer and a lot more land to grow food. Or, well, you could build that ammonia fertilizer with nuclear heat. And I think these are two really drastic alternatives. Either we're going to reduce the Earth's population by 90%, or maybe we'll have to accept a little bit of nuclear energy as we phase out fossil fuels as rapidly as possible. And that doesn't mean that I'm against everything else. I think that wind and solar and hydro, those are all part of the solution. We should try to be 25% nuclear powered by 2050, and that leaves a lot of room for wind and solar. So please keep trying. If you're a solar or wind advocate, please don't stop. But I want to join you in what you're doing.
So how do we reconcile the waste problem? I mean, it's huge, and the danger. And actually, if you could give us some statistics on actual accidents versus years of nuclear power plants being in power, maybe we could talk a little bit about that to clarify. Because I need to be convinced somewhat, but
Yeah. Well, of course, the waste problem seems like a really serious thing when you first look at it. But fortunately, a modern nuclear plant, that's going to produce 4 kilograms of used fuel for your entire lifetime of energy consumption as a energy fat American. That's 4 kilograms. That would fit in this glass 4 kilograms of used nuclear fuel. So is that a big problem? Maybe, maybe not. I mean, it depends on what you know about what is in that used fuel. And that used fuel is 95% recyclable. And the remainder is not extremely dangerous after a couple hundred to a couple thousand years. I'm still a little loose on exactly the physics going on in spent fuel, but the worst case, it will be less dangerous than when you put it into that reactor after 100,000 years. Okay. But the fuel that went into that reactor, not at all dangerous. It has a little bit of energy inside it that we release in the nuclear reaction. And after that reaction, there are a few parts that are very, very dangerous. Okay. If you keep those separate, if you keep them underwater, if you reprocess them like we do in France, you can separate the useful fuel from the fission products. And that's the magic of nuclear technology, is that there's all these things possible, and it's all a little it's scary at first, and then it becomes very exciting to consider, yes, this technology exists. It is possible to do it safely. It is possible to continue to develop this technology. And if you look at my friend's website at whatisnuclear.com, you'll see things like, we have 4 billion years of nuclear fission available. So the waste problem, not as big as you might think. So that's the first answer.
It is in local areas, but it's waste from old plants. Where I live, we have West Valley, and they're still trying to figure out what the hell to do with all of the waste that's sitting in West Valley, New York, all the drums. And it's big and enclosed, and I don't know, how many of those we have. Then we have a place like Hanford. You know about Hanford. Well, give us a little bit about Hanford and tell us, how are we supposed to feel about nuclear when there's a Hanford?
Well, of course, Hanford was not nuclear energy.
Yeah, but it was
nuclear weapons.
Yeah. It's the
okay. Those are two different.
All right,
things,
wait.
right?
All right, let's go. Let's split it up. You're right.
Right.
Because you're anti-war, and let's split that up. My question should have been, Hanford difference. What's the difference in the waste from nuclear weapons to nuclear power? How's that? Is that better?
That's so much better, because
all right.
The process at Hanford was, you take a chunk of highly enriched uranium that's mostly U-235 with a bit of U-238, and you run it really hot for a few months, and then you take it out. And a bit of that U-238 that will have turned into plutonium for weapons. And so what have you got to do? You've got to separate that plutonium-239 from everything else. This is a process called PUREX, Purex, plutonium extraction. That is a intense heat and intense chemical process. Extremely difficult to achieve, but they did it in Hanford. And that's where we produced nearly all of the plutonium pits that America has. And so that waste, that chemical, nasty slurry, that contains a lot of fission products and a lot of very, very dangerous chemicals as well. So getting rid of that radioactive, highly chemically toxic stuff is different from the spent fuel. And spent fuel or used fuel is a ceramic. It's a tiny piece of basically clay that's been cooked, and it just sits there. It doesn't do anything except it's a little warm for a very long time because it has fission products in it.
Okay, fission products. So
Right.
okay, so here we are. We've got fission products. We're talking about fusion. I read and watched as much as I could to get myself ready. I am so not this person as far as physics and all, but fusion. The fusion says that most of the product will be most of anything will be used. It will be used, and there's different ways to split these different. Are they isotopes? Are they, the give us the difference between the fusion and the
Right.
fission. How's that?
Right. So yeah, that's a great place to start. And so with fission, of course, we have uranium-235, and let's pretend that that's all there is uranium-235. You've got an atom of uranium-235. A neutron comes in, and if it's at the right temperature and velocity and all that, it absorbs it and pops apart.
Okay.
And it's two random isotopes that add up to 235.
Okay.
So
If I
two different random chemical elements that add up to 235 now are out there in your reactor. And you kind of have to guess sometimes, and you have to filter it down and make sure that the xenon doesn't leak out like was happening.
Xenon doesn't leak. Sounds like
Yeah.
it sounds like a comic strip character's name. I am Xenon. Xenon warrior princess.
So yeah, there are all sorts of different chemistries involved.
Yeah.
And this has been like studied for decades, and this is why we have very, very highly disciplined work around making sure that we understand what's going on in a reactor and where those fission products go after it comes out of the reactor. That's why we usually hold that fuel underwater in these fuel elements,
underwater,
so that the chemistry is well known and the radiation, the emissions from it doesn't escape. After 3 to 5 years, it is much, much less energy coming off of it. And it is literally air cooled.
It is,
as short as 1 year.
It will be. It is or it will be. I mean, it will be.
Right. Every time you shut down a reactor to change the fuel out, you take a bit of the fuel out and you put it underwater for a year. And then after it comes out of the water, it goes in a big concrete cask until we reuse it in the future, let's say, because it could sit there forever and it would be airstrike resistant for hundreds of years. It would be earthquake resistant and impenetrable to human interference for probably thousands of years.
Considering we have a future. Yeah.
I'd hope so. And even if we put it deep underground, we're talking a couple kilometers down, there's no way that a future human civilization, if we forget what radiation is, will also forget how to dig that deep. So it's not likely that we will accidentally bump into this stuff in the future, as long as we do it properly. We have deep geologic repositories. We have a way of holding it underground. And even if civilization falls apart, it's extremely unlikely that we would hurt ourselves from radiation. We would hurt ourselves trying to get to it, to digging down to it. We would hurt ourselves. So we're getting into the bit of the danger of nuclear waste. And so I'll go just one more step, is that this has happened before. About 2 billion years ago, there was a natural fission reactor under the ground in Gabon, Africa. There's just enough U-235 and there's just enough water coming through a rock formation that a natural fission reaction occurred.
Okay.
It's completely crazy, but it did happen. And the way we found out, we were digging up the uranium and we did the analysis on it and found, hey, there's some U-235 missing. How did it go missing? There's no way that someone could have stolen it and centrifuged it and put it back. It would be broken up into little crumbs, little little sand, basically,
Okay.
or worse, or yellow cake, if they had centrifuged it to change the amount of 235. The only scientific explanation was that substance reacted in the past. And indeed, they looked at the history of the rock formation. They looked at the other fallout, and it's literally what it is when you have fission products in the natural environment, it's called fallout. So they found the fallout and the fission products and the decay chain that resulted in that natural fission reaction. And life went on. It did not end all life on Earth having a natural fission reaction. Just like Chernobyl is not a place deadly to all life. It has slightly less biodiversity than we would like. It is slightly hot in a few places, and it will contaminate you if you go in the wrong place. And so you will, if you take a Geiger counter to anyone who's been in the wrong place in Chernobyl, it will make a lot of noise. That's because radiation, yep, exactly. It's the easiest contaminant to detect. Think about that. You have to actually sample something and react it in a chemical experiment in order to detect chemical contamination. But radiation tells on itself. It blasts out an advertisement. I'm here. Here's a beta, here's a gamma, here's a alpha. You can see anything that's radioactive by the fact that it is emitting radiation.
Okay. So, are there any two-headed deer running around Chernobyl?
There are some moths that have weird spots, I think.
So you've read studies? Have you read studies on that at Fukushima?
Fukushima's
completely
nothing.
Different.
Nothing has happened in Fukushima, unfortunately, because the government of Japan went to enormous effort. They gathered up the topsoil. They, moved all the people out. They kept people inside. Children were actually, greater risk of obesity, not because of the radiation, because they didn't go outside and play.
And that's not typically Japanese at all.
Oh,
no.
So this is sort of the reality is that we've got awareness of the problem with nuclear, and we have solutions that we've put in place, but it costs a lot more to address the problems than what would actually result as harm from those problems. And so there's a lot of us who are really eager to see a little bit more evidence-based response to nuclear disasters. There are some people who say we should not have evacuated from Fukushima Daiichi, that we should have kept that place as inhabited as possible in order to keep the area going.
But wouldn't that have made people that would have been like experimenting on people to keep it as inhabited as possible? Who would want to live there?
That's sort of the ethical question is
a big one, Karl.
Well,
Huge.
Okay, so what are the effects? What would be the effects on you or me if we stayed there? And the answer is surprisingly little. Well, if you have a 30% chance of experiencing cancer in your life, and living in Fukushima Daiichi or living nearby in, let's say, Name or Date, increased your chance of cancer by 0.1% or less, or the alternative being thousands of people died because we evacuated.
Oh boy.
That's the choice. Is we're literally killing thousands of people in the evacuation, or everyone has a minuscule increase in risk. That's what we're talking about.
Okay. And I'm sure that you could provide me with links to put up in the show notes to anybody that, I mean, I have a pretty sophisticated chat and there's a lot going on, and I am saving all of your, I'm starring all of your comments and questions, guys, because we will have my show is very interactive. So with our chat, I mean, the chat is me and I am the chat. So we do that. All right. So we've talked about Fukushima. We've talked about a little bit about fusion. If we are then to start building new new plants, how? Okay, wait. It's the scientists. So we're going to build new plants. What scientists are behind that? What scientists now? Because I know Hansen, I think, and didn't George Monbiot come out? And he's not a scientist, but he's a journalist. Tell us who is. I could say who's buying your shit, or I could say who is understanding, Karl, because sometimes I can play the devil's advocate too.
Oh yes. Well, of course, there are some very notable folks. I think George Monbiot was extremely notable because he had this debate with Helen Caldicott on Democracy Now!
Yes.
And the result was that he couldn't find anything she said credible. And so he's been literally she's
the
saying
scientist.
Things like,
he's not.
Oh,
okay.
Well, there's some scientists are better than others and bring
true.
better evidence than others.
That's true.
And unfortunately, with Helen Caldicott, we get a lot of BS.
I listened to a lot of her. I liked her. I liked her.
It sounds great. It sounds great to say, oh, there will be 4 sieverts of radiation or 4,000 millisieverts of radiation over California the next week. So you better evacuate now. But it didn't happen. And there's, it's one of my favorite things to do is anytime like Paul Dorfman says, oh, the Russians are shelling Zaporizhia. I was like, okay, where's the kaboom? Where's the kaboom? There was supposed to be an earth-shattering kaboom.
I think
Marvin
they're
the
shelling
Russian
each
shows
other.
up.
Yeah, but they're shelling each other.
Right.
Everybody's crazy over there now.
You can't predict disaster and it not come true for people to take you seriously. And in fact, we have perhaps one of the best cases that I have is a lady called Jerry Thomas. And so Geraldine Thomas came to Chernobyl to respond to the accident. And she set up the Chernobyl Tissue Bank in the Royal College of London. Mm-hmm. And I'd say she is one of the best authorities on the effects of radiation on the human body, because she was studying the effects of radiation on internal medicine before Chernobyl, and then has dedicated her career to this, to continuing that study. And you will find videos from Jerry Thomas saying you should not fear radiation.
You should not fear radiation. Well,
yeah, on YouTube, you'll find it. Why we should not fear radiation by Jerry Thomas.
Okay. Wow. Yes, Paul. Paul is like, yes, the questions are going to be read and we are going to discuss them. Yes, Paul.
Right.
Okay. So we'll calm down
get
because
to some of those questions.
Yeah.
Definitely James Hansen,
okay.
George Monbiot, Mark Linus, but foremost, the people who went there, the people who responded to these disasters, they've become pro-nuclear. Isn't that strange?
Who? Like, who are they? What people?
Like Jerry Thomas. I had a fellow who's now working for Bill Gates on advanced reactors, and I've got his video on my channel.
Well, you could certainly give it to me, and I will, link it. I will give everybody whatever they need in the the show notes. That way you guys can, there are actually some people that are in my chat that seem to be very anti-nuclear activists, and that's fine because this is called Environmental Coffee House, and there's a lot under, like I say, always, there's a lot under this umbrella. And I've wanted to bring Karl in for a long time, and this seemed like the perfect time. Plus, I would like to have a debate with Karl, and I wanted it with Richard, who used to follow us. I haven't seen him in a while, but pro and con. And I think that will be something that will come up next. But all right, we have been 38 minutes. So boy, this is going, let me look at some of the things now. Obsolete optics. Hi. Let's put this one up first. Nuclear fission has a whole list of emissions and effluents produced daily, including, but not limited to, beryllium, carbon-14, xenon-133, and tritium. So I'm sure that obsolete, you're saying that is in a negative, obviously negative. I see you're, mystified, the Great Pacific Genocide. It's very real as a result of Fukushima. So we understand you are an activist. And thank you for your activism. Let's let Karl dig in.
Of course, none of those. I'm very unfamiliar with beryllium 7.
Beryllium. I know that beryllium itself is part of the process in the fusion reactions.
Well, yeah, and beryllium is also a part of the weapons. So here it is. Beryllium 7 has a half-life of 53 days. So after 10 half-lives, that beryllium will be gone. And so we're talking a year and a half. Any beryllium 7 coming from a nuclear reaction will have decayed. It will be gone. Carbon-14, of course, you might have heard of carbon dating.
Of course.
Carbon-14 is everywhere. Everywhere in our atmosphere, cosmic radiation, solar wind comes and strikes carbon atoms and makes carbon-14. So we have carbon-14 in our bodies right now. You can't get rid of radiation. It is with us always. We evolved with radiation. Our body repairs this small damage that comes from radiation. And in fact, most of the cellular DNA damage that comes into our body happens because we eat food, we breathe air. It is the metabolic process that causes cancer. Radiation is a very small impact on the cancer risk for the vast majority of people. It's mostly chemical and metabolic processes that cause cancer.
Except when you're in the middle of Chernobyl at the building, and come on, those guys were totally exposed.
44 people. Yes, that was horrible. All the workers who died from acute radiation sickness.
Right.
Completely true. And maybe a couple hundred more people had long-term health effects from acute radiation exposure, from very high levels of contamination. And in fact, thousands of people were exposed to radioactive iodine. That's probably the most significant substance that was in their question, is the iodine-131. That goes away very rapidly. After, I think, about 70 days, I think its half-life is 7. And so 70 days, that's 10 half-lives. That's going from half every half-life. And so after 10 half-lives, we're talking 0.01% remaining. So it's basically gone at that point. And it is the worst. And very simple public health procedures would have prevented that problem. Chernobyl happened in the middle of the secretive weapons project of the Soviet Union. This was a secret city that no one was allowed to know what was going on there.
Oh, like, so, of course, things we have here?
like Hanford.
Sorry.
Yes, absolutely.
Secretive,
It's all
yeah.
weapons related. And that this is the worst is the worst crimes of nuclear technology is when you use it for weapons.
It is the worst. I have to put this up. Obsolete optics again. And I'm going to put his stuff up, and I'm going to put up other people's 750,000 men entombed Chernobyl, thousands of birth defect babies abandoned in Ukraine and Belarus. Do you mean that 750,000 people died or 750,000 worked on it? Obsolete. Is that what it is? That's a lot of people.
It is a lot of people. And in fact, we have folks like Jerry Thomas who know the truth is that, yes, there were a lot of people exposed, and some of them had cancer from iodine-131. They had thyroid cancer, and you will meet them because they have a scar right here.
Mm-hmm.
They'll call it the Chernobyl necklace.
Oh my God.
Those are people who survived that disaster.
Oof.
And thyroid cancer is 99% survivable. They will cut out your thyroid with a little incision, and you will take medication to replace the thyroid hormones for the rest of your lives. Mm-hmm. It's horrible, but they did survive. And this is the real effect of Chernobyl, as opposed to, I'm not sure where 750,000 people comes from. Even the Green Party of Europe's best estimates were that 80,000 people would eventually die from cancers as Chernobyl. So that is the most strongest estimate in favor of the anti-nuclear position. And so this
sacrifice zone. It's a sacrifice zone. Really, right?
Theoretically, it's a sacrifice zone, but
right.
after 3 or 4 more half-lives, it's essentially not worse than most places in the world in terms of background radiation. In fact, we go flying. You will fly to Belarus and then tour Chernobyl exclusion zone. You will get more radiation from the flight.
Wow.
Yes.
All right. I have a question I need to ask from Paul Mobley. Hi, Paul. And he's been very much wanting to ask you the question. We're going to go all the way over to Japan. And his question is, what is the pH inside of buildings at Fukushima?
I don't think that pH is necessarily something that I would be concerned about. I would be concerned about the millisieverts or the sieverts of radiation inside those buildings. This would be the amount of energy coming off of that corium. This is the melted fuel. And in fact, as long as that is contained, I'm not concerned at all. Inside that tomb, we need to break it up. We need to cut it up with robots, and we need to remove that melted fuel. And then it will be the same as other spent fuel, other used fuel. It will be in concrete casks. It will not be a danger if you don't interact with it.
Yeah, that's the thing.
And that's why I like to say that,
not interacting. Don't get it out of sight, out of mind.
Do not eat nuclear waste. Please don't eat nuclear waste. Please, just don't. You don't need to eat it. It's not worth the calories.
So what has been, he's back on, pH, what has the pH been in the containment vessels leaking water? Has there ever been redox conditions?
So there's a few terms here, redox, or is that relating to...
Redoux? French?
Is that relating to fuel reprocessing?
Well, here it says...
I'm not sure.
Redox conditions causes radionucleotides to become water soluble.
Yeah, I don't see that. Okay, so if some things, of course, are water soluble the minute they come out of the reaction. And we're talking things like cesium-137.
Uh-huh.
That is the most concerning contaminant in my mind. And in fact, over 90% of the CS-137 in our environment came from when we exploded 530 atomic weapons in our atmosphere. This is why you can encounter CS-137 in the ocean, in the fish, and it will not necessarily be from Chernobyl or Fukushima. It would come from existing fallout, unfortunately, from nuclear weapons that happened decades ago.
Oh, yeah. Before we really even knew. And the scientists had to have known. They had to have known when they did the testing back in the atolls of the island nations that they did. They had to have known that there would be. You don't think so? That they didn't know?
Funny story about that.
Okay.
Castle Bravo was far more energetic than they had predicted. It was
predicted, yes.
Yeah, and this is sort of like right, and this is the reason that the National Ignition Facility has been a big deal, because we know from that experience that we can't simply rely on predictions and computer simulations. We need to back it up with evidence, with hard data, in order to really know what is going to happen in those reactions. So we'll see very soon, I'm sure, we will see some other chemical elements mixed in with an experiment one of these days in order to prove, okay, the decay chain of these plutonium pits is not going to in some way endanger the reactivity, endanger the chemistry of what's going on. And this is an experiment that I don't expect to happen very soon, but I think that it will happen someday. And that would be to, again, prove beyond the shadow of a doubt that these devices are going to behave in a predictable manner.
Okay. All right. So I'm going to go back, and I'm trying not to jump around too much with this. Let's see. We already went with that. Well, Paul says he has the evidence. He has the evidence. Paul, write to me at environmentalcoffeehouse@gmail.com. Perhaps you might be the person that will do the debate show. We'll see. I'm looking for candidates. Yeah. We already have our pro right here with Karl, and I would love somebody that would debate him, because I would stand back and let it rip. All right. So, well, yeah. Thank you, Paul. Thank you so much. Okay, ask you about biological uptake of radioactive isotopes in the food grown on farms surrounding existing nuclear power plants or nuclear power plants that have been in service. The studies and the information about that.
Well, fortunately, you don't need a study to consume that food. You need a Geiger counter.
Okay.
It is in fact required by law before you can buy produce in that region of Japan that it will be tested for radiation.
But what about the United States?
Well, and how do you tell then the difference between natural contamination and contamination caused by nuclear energy?
I would think that there is a scientific, there are different types of levels, maybe more radiation that you would see indicative of a nuclear plant being around. I mean, look, I'm a shot in the dark here, so.
You know what? You would assume so if you didn't have the evidence. And there is this thing that the government of Canada put out. It's a website explaining the KIKK study. So this is the best study we had in order to correlate cancer incidence increase surrounding nuclear plants. And this is not to say that they found the isotopes or they found the contamination. Because as I've told you, radiation is easy to detect. And so if there was a contaminant coming from a nuclear plant, we would find out. And we regularly do. We find the tritium, we find the plutonium buildup in the filters, we find the xenon releases. That's why we had 3 Mile Island. We knew exactly how much came out of that plant because of the samples that were taken. And when I spoke with Lake Barrett, we went over all these discussions over, okay, how do we know what the dose in the area was? How do we know what the risk was? And that's because we had these very, very aggressive estimates based on samples taken. And the worst of those estimates were not as bad as predicted, fortunately. So here's that nuclearsafety.gc.ca study, the study from the Canadian Nuclear Safety Commission.
Do you want to try sharing your screen? Although it probably might screw everything up. I
could try that. Let's try.
I don't know. I have to see. We did it. We did it last night in my test stream, but I don't know if it would go in the middle of us. But if you want to try it, I'll see if I can get it up there, and we can have okay. And I'm going to assign this. Let's see I'm going to assign it to the middle and see if it comes up. No, it's not coming up. Oh, that's you.
Okay.
No, that's not working. That's you. Uh-oh. I don't know if that's going to work. Solo? No, it's not going to work. I'm not going to mess with it. The show is good and it's working.
Yeah.
And we have a million questions.
Yeah, you can share this study later, and this is where the German government said, or the study said that, yes, there's an increase in cancer. And then we found, they had not found an increase in cancer surrounding nuclear plants. They had found an increase in cancer surrounding industrial sites because there were areas included that did not include an actual nuclear plant, only one that was planned. And guess what? There's other factors involved. There's, military communities. There's other industrial effects in the area. It could be chemical pollution. It could be the fact that people were moving to a place with very high quality healthcare. And so they were screened for more diseases than they would otherwise be screened from. So there's many different reasons why you might see an increase in cancer that's not linked to radiation. And in fact, the accidental inclusion of planned nuclear plants rather than only actual nuclear plants, that shows, and also scientific control would show this, that there was not a definitive link between nuclear plants and an increase in cancer. Okay. Is it possible? Absolutely. But we need to show evidence, we need to show the pathway, and we need to know what that range of risk is. Because below a certain level, radiation is difficult to show that it harms the body. So below, let's say below 400 millisieverts a year.
Oh, okay. You're qualifying that. I mean, radiation harms the body. It's just a given.
It can. And the body can heal itself. Now, the question is how much radiation? It's like water. How much water can you drink? You can drink enough water to break your brain. So and you can drown in water.
Yeah, but you're really not making the same equivalent of water to radiation.
I'm saying there is a dose at which radiation is safe, more or less acceptable.
Well, okay. Well, that's what they say.
I won't say it's safe.
The medical industry says that. The medical industry says that because we go for MRIs, we go for CAT scans, we go for those things, we go for X-rays.
That doesn't mean it's safe. It means it's worth the risk. And every medical procedure, it's worth the risk.
All right. Worth the risk. Okay. Right. Now, we've got so many people who've got so many things, and I'm going to try to give a question to Jean. Jean is, we love her. She's from Costa Rica. Okay, Sandy, could you please ask him to talk about the problems with hotter water from our warming planet being used to cool nuclear plants? Some plants have had problems. Excellent question. Which one I was thinking about.
Yeah.
Water is life and we're screwing it up.
Well, the fact is that we've screwed up the planet, and that makes water all around us hotter. Most famously, there are places off the coast of some Scandinavian countries and some rivers in France, which are not allowed to use the full potential of that nuclear reactor because the water in the environment is very, very hot. And what does that mean? Does that mean that the plant is in danger? Does that mean that it is boiling the fish? No. It means that by law, you cannot release water that's greater than a certain number. Well, what if that number is just how hot the river is? They make an exception. They actually make an exception. If it's something like 23, 24, 29 degrees Celsius, I forget the exact number. It's somewhere in that range. Fairly hot for a river. But if the environment itself is that hot, what are we going to do? The earth is boiling itself. And so if we need to use 1/10 of a degree to produce a little bit of clean energy, maybe we should.
Keith says it means giant catfish. Sorry.
Giant. Yeah, it does. And
Keith
we've
is
got
from your area, by the way. We have a lot of people from your area.
Oh, nice.
Yes.
So we do have a bit of a altered environment around Indian Point, around Diablo Canyon. These are all nuclear plants that do not have cooling towers. They let out the water directly into that great big river, which is not the cleanest river in the world, by the way, in New York.
No, I grew up on the Hudson
Pacific
River.
Ocean. Yeah, and so you have a choice. You literally have a choice between a oil gas cogeneration plant that should have been shut down decades ago, that is literally polluting the water with chemical pollutants and heat, or Indian Point that was adding no chemical pollutants and heat.
Heat. A lot of heat. I dated a guy that worked at Indian Point. What a whole thing. Oh, really, it was a big thing. It was back in I won't say how old I am, but it was back in the late 70s. And I mean, he came out of work. It was a huge production for him to go to work and then come out of work and how he had to change and be decontaminated. I wasn't even sure at that time I wanted to touch him. I did for about 3 months, then I broke up with him. All right.
You would be able to tell just the nuclear engineer's girlfriend take that Geiger counter.
Yeah, right. I didn't know anything. I was 18 years old and a moron. Okay, so let's go. And I can say that, guys, very clearly. At 18, I was a moron. All right. I know Forest Dweller left because he got pissed off because I love the guy, but he didn't have patience for this. And he said, Shil Yadev says, industrial society destroys mind environment. Environment.
And environment, yes.
Environment. Destroys mind and environment.
My perspective is that just like a medical procedure, an industrial advancement or industrial society is an intervention, and we choose to use industrial development in order to improve our quality of life, in order to lengthen our lives. And that's how we're like online right now. I mean, where would we be without computers? We wouldn't be having this argument.
And we're not arguing. We're discussing. Right. It's not an argument. It will be an argument when I bring the person that you debate on. That will be an argument. I am merely the facilitator of information. Okay. because I'm not giving an opinion about it's not that's not my role here. All right, so obsolete optics, gotta love you, hun. I'm so happy you're here today. Ask him about biological uptake of radioactive isotopes in the food grown. Oh, did we ask? Did it? No.
Yeah, we did this.
We did this exact question. The uptake of the radioisotope. Okay, then let me do.
It happens, and you test it, and you don't get that radish if it has a contamination.
All right. And then, of course, my buddy, who is a very good friend, Bila Lugrisi. What? Hydrogen bombs aren't destructive enough? I mean, he was just making a comment, but I thought I'd put it in. Right. It was from earlier. He's a very good friend of mine. He's, we're, not exactly the fan of nuclear. All right. Surfer Norm, let's bring you in. Hi. Glad you mentioned Hanford sitting up there too. I have one of my own 2 miles away at the Santa Susana test site, East Ventura. Well, back to Looney Tunes. So Norm, you feel like it's Looney Tunes to have a place like that where you live? I mean, or what do you think about that place? Santa Susana.
I think that the connection to the nuclear weapons industry is very clear. The Santa Susana Field Laboratory is where that happened. It was part of both chemical and nuclear experiments.
Okay.
You'll find it really easy to blame nuclear for any problems. But more likely than not, contamination, cancers, health effects from living near Santa Susana comes from chemical contaminants, most likely.
Well, I think that it's time for the environmental coffeehouse flush of the day, where we regularly flush away something we don't like, and it sounds like we want to flush away that plant. So there you go. Goodbye. Wouldn't we all love to flush that plant away? It's something we do here. We flush what we don't like away, and we just did that. Okay, so where are we at? Oh my God!
Could I tell you about my own local nuclear disaster?
Yeah. Yes. Do we need background music for this?
Well, we don't need background music.
I'm putting it on.
Okay. And I got to this during the talk from the Thorium conference that you linked. It's one of my slides in there, so keep watching. But in Harborview Research Hospital, as a part of the University of Washington, they had a blood irradiator device.
Ooh.
In May of 2019, they were trying to decommission this blood irradiator, and they sliced it wide open. Many workers had to go to observation. The fire department got called out, and unfortunately, the cleanup was not as good as it could have been. So we've had to retrain our fire crews, we've had to update our procedures, and we've learned a lot. Mm-hmm. But this incident, which is the Harborview cesium source disposal accident, this has more impact to me and my local community than any nuclear energy disaster ever, anywhere.
Well, that's pretty scary. Yeah.
But it just shows you that you can't single out one application of the technology and say that that's the bad thing. And we know that radiation in healthcare is important. It is worth the risk. When you're talking about cancer treatments, that is literally using a radioactive substance and putting it into their body, using targeted alpha therapy, using different exposure doses to that cancerous sub part of the body. These are important uses for nuclear technology. And we know that they're worth it because it keeps people from dying. And so you have to take it on a case-by-case basis. Every single piece of nuclear technology, you have to understand the risk and the benefit. And for me, for climate change, nuclear energy is absolutely worth it.
Well, you're not alone, obviously. There are others besides Monbiot and, well, who's not a journalist, and Hansen. Is Hansen actually still an advocate?
Yes, he still is.
He is.
He's definitely retired, and he's definitely, in the middle of, enjoying his retirement. But he has also continued to speak in favor of nuclear energy for many years now.
Okay.
He went to, was it COP 19, I believe, and in Paris, and talked about the need to continue to use nuclear energy to address climate change. It's not something that we easily give up. I would be very surprised to meet a scientist who gave up their support of nuclear energy for any reason.
Really? Okay. That's interesting. All right, we are cooking with gas. All right, here we go. And obviously, we're not rushing through this show because there's so much out here. Everybody's really invested in this. Let's go to who hasn't had a turn? Because, all right, let's see. Lightning Rod from Canada. Hi, Lightning Rod. Do you think that the burning of fossil fuels will ever be reduced voluntarily, or do you think it will be forced upon us?
Unfortunately, I think that we need collective action in order to reduce fossil fuel use, because it's so easy to use coal, to use oil.
Yeah.
When you have no energy and you are desperate in order to survive,
Yep.
you will use coal to cook, to keep yourself warm. It is extremely challenging to avoid fossil fuels. And so we need to use technology in order to uplift our fellow humans and help them avoid using fossil fuels.
Okay. And do you understand what the aerosol masking effect is, by the way?
Mm-hmm. Yeah. That is.
Can you talk on that a little bit, since it is, I mean, not that it, well, I mean, the use of nuclear energy could come into play here. So let's hear what you have to think about that.
So aerosols in the atmosphere, or global dimming, that's what you're talking about?
Yes.
So this is using fossil fuels, using oil and coal particularly. They emit nitrous oxides, sulfur oxides, and particulate matter. And each of these has a bit of a dimming effect where the sun doesn't penetrate through the particulate matter. And in fact, it reduces the amount of heat that we absorb at ground level.
Uh-huh.
And so the global dimming, when coal was very, very much in use in America and Europe and England, we avoided a little bit of warming across those regions because we were using so much coal. Now that we're switching to gas, the sun's hitting us at full force, and we really are feeling the full effects of climate change now that we are not emitting all of those aerosols into the atmosphere.
So that's not going to change. We go to nuclear power, we're still then not going to have quite the aerosol masking effect. So, I mean, it's kind of a...
We could do it on purpose. We could. Some people are
chemtrails.
In favor of solar radiation management.
I know, and
not literal airplanes flying around right now.
I know this.
Water, mostly water.
We call them cap trails, by the way. Capitalism trails. Boy. Well, you go flying.
Yes,
it's capitalism trails. They're cap trails. That's what we call them.
Yeah. So the adding like aluminum sulfates or different sulfate compounds in the atmosphere is one idea. I've discussed this on my show once or twice.
Okay.
It's something that could be tested on a very small scale, but we've really got to pay attention to the chemistry and the effects on the environment
Mm-hmm.
and the downstream effects.
Mm-hmm.
But just like any medical intervention, it might be worth it.
Yeah, Donald, chemtrails or comtrails. It's cap trails. No, capitalism trails. People fly because of capitalism. That's why we call them cap trails. It's a little joke, And me and Sam Mitchell came up with that joke. Okay. So oh, hi. I just have to say hi to Olawale Blue. He runs the Discord. Okay, so let's get to some more questions here. A lot of, the same questions. Let's go to Nicholas, who asks, hi, Nick. Nick from Mexico, who I know personally. Does he believe that nuclear energy production will be a bridge producer as we proceed to fully sustainable energy production? I hope.
I hope so too. I think that when it comes to the length of that bridge, though, it is a very, very long bridge. We have 4 billion years of energy available through nuclear fission. That's uranium, thorium, and breeder reactor technology. Mm-hmm. That's seawater extraction and mining. That is a lot of work to get the most amount of energy out of our environment, but it should be worth it because we need to get off fossil fuels very quickly. After 4 billion years, we won't have wind or solar because the sun will be gone. By then, we will need to move to fusion. And so whether or not we get to fusion energy on Earth, we need to get fusion somewhere. I think that
orbital, like Mars, Elon.
Not in our solar. After 4 billion years, humankind will have left our solar system.
Yeah.
Yeah. Elon can have Mars. He can have Mars. I'm going out.
He can have Twitter.
Yeah.
Okay, sorry.
So yeah, I think that as a bridge, the most likely destination would be orbital solar or fusion or some other clean energy future. But this won't happen for hundreds of years. We need to reduce fossil fuel use as fast as possible. And that means, in my opinion, 4 new gigawatts of nuclear on average every month as soon as possible to 2050 and beyond.
And beyond.
And if you think we can do it with ground level wind and solar, please try. Please keep going as fast as you can. We need all the clean energy, all of it, as fast as possible.
Well, I'm sorry, but a lot of the people on my channel don't think we're going to do it with anything, as doomers do. Not think that we're going to get out of this mess. Okay, let's go. Mike. Oh, Mike, let's see. What about the elephants in the room, like displacement of emissions in our atmosphere? I guess that goes back to the question, the global dimming question. So we're jumping around a little bit. What about the elephant in the room, like displacement of emissions in our atmosphere?
Yeah, I'm not sure that I completely understand this. So we're displacing fossil fuel emissions and we're replacing it with something else?
Well, Mike, if you're here, answer that. All right. I wanted to get, okay. Now, Bila, again, we're going all over a little bit, but now those animals in the Chernobyl exclusion zone are being highly radiated by Russians kicking up the contaminated soil. Russian soldiers got radiation poisoning and had to leave. Can you address that a little bit?
I don't know that all of those reports were verified. I know there's a lot of propaganda flowing on both sides in the Ukrainian war.
You
It is,
think? Yeah.
it is absolutely likely that some soldiers got more contamination than they were planning on. And it may be possible that they suffer some health effects of it. They could see a shorter lifespan, especially if they were dug into really contaminated soil. I doubt that that will be the case, but I can't say it's impossible.
Okay, let's see. Gene again. Gene, could you ask Sandy? Could you ask him to talk about the pro? Oh wait, we did this already.
Yeah, we
Sorry,
did this.
I had
Yeah.
up. Sorry, I have not taken them out. All right, let's see. Lightning rod again. Did I do this? Did you think that the burning of fossil fuels? Oh, I did it already. Holy shit. Oh, sorry. All right, let me find one I didn't do. Sandy, please ask how many. Okay. How many nuclear power plants do we need to build to supply the energy that we all need? One for X number of homes. And then also, I would like to add to that, what about developing countries? Because that then goes into the whole population issue also, give energy and all that. So do you have and I'm not giving either way. I want to hear what you have to say.
So napkin level math, like back of the napkin level math, we're talking about the average American's total energy consumption of being about 2 kilowatt hours every hour. And so what that looks like, that's about 2,000 kilowatts, multiply that by 1 million to get one nuclear plant. So for every couple of million people, for every 500,000 people, we're looking at about one nuclear plant. And that's just napkin math. That's before efficiency, by the way. So we need to reduce our energy use. You might have heard of something called the 1 kilowatt society. This is the idea that we can reduce our energy consumption so that one nuclear plant goes for 1 million people.
Okay.
Wouldn't that be nice?
Yeah, well, it by the way, guys, we've gotten 4 thumbs down, and I want to thank you, because thumbs up and thumbs down helps our channel be seen. So keep them coming. Thank you. All right. So let me go and see something that we have not, that I haven't screwed up. I asked that. All right. Earl, what if Putin uses a nuke in Ukraine? What do we do then? I mean, it's a reasonable question, even though we're supposed to be talking about fusion versus fission. But what if? And what are your thoughts? You're in this.
Oh boy. So I'm not a fan of nuclear war.
Obviously.
I'm not a fan of really considering the nuke of nuclear weapons. It's basically a societal singularity. Actually, there's posturing, and there's saying that they're going to throw a bomb, and if Ukraine is hit by a weapon, the fallout from that weapon will drift to all over the place. It could go to Turkey. It could go to all the nations west of Ukraine. It could go back into Russia. It's extremely bad just on a local level. Putin will alienate his neighbors, his allies. No one is going to be his friends if he throws a nuke at Ukraine. I think more likely he will single out an adversary elsewhere in Europe or America. And then we are in for it. It's then we really find out if our nuclear weapons work. Forget the National Ignition Facility experiment. We will have an atmospheric test again, because it's full on nuclear war, and even a limited nuclear war, millions of people are going to suffer, if not die. And I'm not a fan of that.
Well, then maybe we should listen to that Jeffrey Sachs, who just is screaming about negotiate, negotiate, talk, talk, talk. Perhaps. It's a very scary topic that when we go there.
Yeah.
Okay, let's see here. Sorry, I'm so awful at this. When I put them in, they don't. All right, let's see. Paul Mobley. Going back to what we were talking about before, you have to use a mass spectrometer or a scintillating crystal to know what's in food. Geiger counters do not work for food. Maybe that's something
No,
you need.
I don't believe that.
Really?
I believe that if you have a substance emitting radiation, then okay, if you have any emissions of any amount, and if you know what something called Avogadro's number is, that's 10 to the 23rd is the order of size that we're talking about. So any significant amount of nuclear radioactive material that's going to hurt you is going to be at least trillions, if not far more, atoms. And we are detecting individual decays with the Geiger counter. So if you're hiding a pellet of something deep inside, let's say that there's some substance that only shows up in the pit of the fruit and it only migrates to the pit of the fruit.
Yeah.
Well, if you're
It's all
allowed to
different.
buy that fruit, you're going to have to cut it open and expose that
Test it
pit
yourself.
to a Geiger counter. You're going to have to, and we know how the chemistry works. We know how the biology works. There's tests, and if you live in Japan, in that region, you are required to test your food.
So basically, kitchen Geiger counters for all, and they'll be sold on QVC and HSN. Okay, kitchen Geiger counters.
Or they'll be there at the market right next to the checkout stand.
Maybe I should get into it. So, come on, guys, who wants to get into the Geiger counter business? All right, I don't mean to laugh. Of course, it's a very serious. All right. Well, here, Blocksworth Snout says that alpha, beta, and gamma radiation, these enter the body very differently. But we're not doctors, of course.
They
It's
don't
not a
enter
doctor.
the body. So gamma passes through the body. Alpha bounces off the body. Beta might penetrate the skin. But this is the difference between radiation and contamination.
All right.
So let's go back to basics. An atom that is radioactive emits radiation. Alpha, beta, gamma, those are the emissions, the radioactive emissions. The atom where those emissions come from, that's contamination. That's your uranium, tritium, cesium, polonium, all of the nasty stuff. Those things enter the body based on their chemistry.
Okay.
So if you're talking about cesium, that comes into the body and it sticks around for quite a while. Plutonium coming into the body, that sticks around basically forever. It's the bone seeker. It's really dangerous stuff. You do not want to eat plutonium because it will not go away. Uranium oxide especially, that's going to pass right through the body. You'll literally take it in and poop it out in 3 days. Okay. Other things, different rates of bioaccumulation. And so we're talking about bioaccumulation is a serious issue, like different mushrooms, different, pigs and fish, bottom feeding fish, bad for bioaccumulation. Definitely have to be careful about testing those. Like slice into the liver, put a probe into there and make sure that it's not, extra hot.
Extra hot. Like me. Extra hot.
Contaminated.
Extra hot with my WASF hat. Okay. All right. So here we go. Give me a minute and forgive me for being. Oh, does Karl believe in that the future we can achieve free energy for everyone anywhere?
We defeat capitalism and energy will be free.
And will it be free even if it's not fusion?
Yeah. Well, I mean, without capitalism, energy will be a human right. And
That would be just
right?
yes. And it's
Wouldn't
right now it's magical thinking, but it would be a human right. It would be a human right. Okay, I like that. Although we still
I know
have
what the
to-
real question is. There's this prediction that we would have energy too cheap to meter. And what would that be like? That would be like water is for most Americans. You would hook up to an electrical grid and you wouldn't really be charged based on how much you used unless we like saw that you were just throwing it away for no good reason. But in some places back in the day, I'm sure water was less of a concern. We wouldn't meter it so aggressively. You could take it out of the well and no one was really watching you. Is that possible? I doubt it, because we're so technologically advanced today that we're literally turning kilowatts into Bitcoin. and so we've
What a
lost
waste.
that because of our capitalist interests. We've made it so that electricity will never be too cheap to meter because we will turn electricity into Bitcoin or some other cryptocurrency.
some other ridiculous thing. I hear you.
Right.
Okay, let's see here. I found those. Okay, Gary, I don't know if Gary's still here, but he goes back to the waste issue. I think he was one of my illustrious thumbs down. Nuclear. Find a use for waste, maybe then, but it's just too easy to fuck up the process. It's too dangerous. Do you think it's too dangerous?
I think that I can't say that it's perfectly safe. I can say that it's worth the risk because we have energy poverty around the world, we have climate change, and we have fossil fuels. And all of those things are worse than nuclear waste.
Right.
So what's the danger? If you're not eating it, if you're leaving it alone, if you're putting it in a deep geologic repository, who is it hurt? Show me the person hurt by nuclear fuel in a dry cask. There is no one that's ever been hurt by nuclear fuel that's been put in a dry cask. There have been a few accidents. And why are they called accidents? Because something went wrong.
Yeah.
Because there was a mistake in procedure, because there was a natural disaster. We can overcome all of those problems. And when it's properly handled, when it's been properly treated, it's in a dry cask kilometers down where no one will ever be hurt by it.
So you have a little hopium going on there, that we can do all this.
Yeah. And Bella, I'm sorry, I'm spying on chat now. Bella just
Go
mentioned
for it.
WHIP.
You're not spying. You're helping.
I love WHIP. If you look at my channel, Your Environment Seattle, here on YouTube, or maybe it's Seattle Friends of Fission, I have a couple different channels.
Okay.
You will find Jim Conca, and in fact, here's a good one: the billion-year secret, or the billion-year nuclear repository, something like that. I need to find it now.
Billion year.
Because WHIP is literally, it will not have a water intrusion for a
What
billion
is it?
years.
Those of us
It's
that
the Yeah, okay, so let's talk about WHIP. WHIP is the Waste
Whip it.
Isolation Pilot Project. WHIP it. Real good. It is the place where the United States is putting its weapons waste. Unfortunately, we've decided to find the best place to store nuclear spent fuel, and we decided to put weapons waste in it because it's not retrievable. And weapons waste, we never want to retrieve.
Oh.
So for used nuclear fuel, we have this idea that we're going to burn it up in a breeder reactor someday, but you can't do that with WIP because once you put it in the Permian Salt Basin salts, that formation starts to close around it. And so there it is, the secret billion-year waste repository is what I called it.
For nuclear weapon waste.
Right.
Why are we even having nuclear weapon waste? And Bila said it's closed. It's permanently closed. But why, if we're not using...
Untrue.
It's not true? Okay.
It closed down because someone put the wrong chemical packing around some of the waste. And in fact, it reopened in 2018 and it's under budget still, despite a chemical accident that caused some contamination. They had to shut down some of the tunnels and they just let it close up. And the salt formation is doing what it's supposed to do. It keeps it separated from the rest of the environment. And WIP is literally the perfect nuclear waste depository. It's soft salt rocks. You dig it really easily. It closes up around anything that you put inside of it. And the water takes millions of years to move inches through it. So this is literally the perfect place to store any nuclear waste, even any chemical waste. We could put it in there and it would almost be impervious to any water intrusion. So this is the place where we should be putting anything that we want gone forever. But I think we need to turn all of that used nuclear fuel into recycled breeder fuel because we need to get 4 billion years of energy out of it instead of just a couple thousand years.
4 billion years. Okay. That's a little out of my wheelhouse. All right, OG Skywatch. If you're spying, like you said before, can I ask about the Bill Gates reactor? I'm being ignored for some reason, and you're not being ignored, my sweet OG Skywatch. You're not being ignored. There's a lot going on out here, and so, you're not being ignored. I don't ignore anybody on purpose. Okay.
Right. So, in fact, I spoke with Mark Werner from TerraPower, and I think that they basically tested out their press release and their press conference with the Seattle Friends of Fission. And so if you find either Your Environment Seattle or the Seattle Friends of Fission are my two YouTube channels on this topic, you'll find us talking about the Natrium project. The Natrium was to select 4 different possible sites in Wyoming. Kemmerer, Wyoming was selected as the ultimate place where it is replacing a coal plant. Hooray for that. We're taking out dirty coal and we're putting in advanced nuclear. The worst news, however, I've ever heard, though, was that because of the Russian military aggression, we don't have enough fuel to run this new nuclear plant. We need high assay low enriched uranium. That's the term. High assay low enriched uranium, HALEU fuel, or 20% 235. And so we need that level of enrichment in order to run the Natrium project at the expected efficiency and output. And unfortunately, American enrichment facilities are not up to speed yet. Hopefully, we'll see something in the next few years that either improve our capability to deliver that fuel or lengthen the time constraints on the advanced reactor project. Because right now, it looks like Natrium might be too late and might be missing out on its funding if we don't get the fuel needed to finish it on time. That would be really bad. And thanks Russia, thanks Putin for screwing up a good thing.
Yeah, and he also makes me mad because he wants to drill the Arctic, and that's where I stay, and I don't go anymore through the whole 9 yards because it's just a shit show. All right, on my channel. I have a Nadia question that I want to find. Nadia, where's Nadia? Sorry, guys. It's just the questions, even when you save them, they don't seem to come in any kind of right order. So it's kind of hard. Nadia, here we go. All right, Nadia. Peak uranium is deep trouble for all of this. Replacing all coal with nuclear will run through reserves in 20 years, and thorium is still pretty experimental and not infinite. What do you think of her comment there?
Very, very fortunately, we have recent advancements in seawater extraction. So when we talk about peak oil, we thought we were hitting peak oil back in 2004, 2006. And then, boom, the fracking revolution reversed peak oil. It extended it until 2018 was the last time that we had to worry about production. Mm-hmm. And we may, in fact, have record production again in the future, unfortunately. And it's like I said before, fossil fuels are really easy to use. Until we're forced to do something else, we will continue to use fossil fuels. Until something is more energy efficient or cheaper to make, we're going to be stuck on fossil fuels. And so, yes, peak oil might be coming, but that is not as big of a problem as I used to think it was. Peak uranium, never going to happen. Unless we switch to nuclear energy overnight, we will not run out of uranium. And even if we did, we would have thousands of years, because you can get uranium out of seawater. It's a salt-like chemical. It sticks to things, and it goes into the ocean water from all of these geothermal vents and all of these rock interfaces on the seafloor. So we could extract uranium from seawater. Pacific Northwest Lab, where I'm at, does it regularly. They've got experiments, and they're working on the economics now.
And where you're at, you work there? Bless you. You work there?
Oh, I wish.
You wish. You wish.
I wish. It would be such a cushy job working at a research facility. I worked in video games, and recently I switched to broadcast technology. So I like the idea of going back to school and getting into nuclear, but that's a lot lot of school and a lot of engineering.
Yeah,
for
it would be
someone
starting
my
over.
age.
Yeah, well, you don't look that old, but yeah, it's still a lot. All right, let's see. We are an hour and 41 minutes. We're going to go to 2 hours on this show because there's just too much information. And thank you guys. I love you. And don't forget, like and subscribe, buy me a coffee, and all the happy horse shit you have to do for the channel. Okay. Because it really does help, guys. I have to tell you, it's, I love you all. Okay. Now that I did my little public service message, and they all know I love them. Earl, who is such a fan of the flush. Finland has quite a plan for their nuclear waste already in action. Have you seen that?
Yep. Finland will be the first deep geologic repository for nuclear fuel. It's a wonderful project. I think it's called Onkalo. It's near the Olkiluoto nuclear plant, which is slowly coming up to speed. It's been put online, and I think it's connected to the grid. I'll need to double check my update there. But yeah, Finland is doing really wonderful things. In fact, recently I spoke with the Finnish Eco-Modernist Society, or Finland's Eco-Modernists, Juho, my friend Juho from Finland, was really enthusiastic.
That. And I thought actually he was really good. Believe it or not.
Good.
I was waiting to go in and hate everything, but I didn't. So, I try to keep an open mind, and that's what all I ask of my chat is to keep an open mind. And you don't have to love what you hear. You just keep an open mind and hear it. That's all. That's what my channel's about. Okay, our channel, because we have a lot more people. Jean, and this is a good question. How long does it take to shut down a nuclear power plant so that if left abandoned with no problems for when we all start drying off? Thank you, Jean.
Well, if in the specific scenario you're talking about, it's about a week. So after
a week,
after a couple of hours, sorry. So let's say there's an earthquake, right?
Oh, I see. Yeah.
Bam. It's called a scram. And that means that these control rods get inserted into the reactor, and that stops the nuclear part of the reaction. However, there is still a lot of heat in that reactor. There's about 7% of the heat just latent sitting around, and that can still boil water. This is the heat that caused the Fukushima Daiichi meltdown, and that caused the fuel elements to start to crumble.
Okay.
And when those fuel elements crumbled, it split the water into hydrogen and oxygen, and so you got a hydrogen bubble inside the building, and that is what exploded at Fukushima Daiichi.
Yeah, we watched.
So that's what we're trying to avoid. Yeah. That took about 24 hours for that accident to develop. Their batteries lasted for a couple of hours. They had batteries to run the pumps, but eventually those ran out. They're old, bad batteries. They actually had a sister plant called Fukushima Daini.
Yeah.
And at that plant, the batteries worked long enough to get a cable to plug in the cooling system. So if we're all dying, then we've got time. We've got at least 24 hours. We've got at least a couple of weeks for it to go into cold shutdown.
Okay.
The next question is, how do you get to very low risk or no risk? Well, you can weld shut that reactor vessel. Once it's in cold shutdown, you can weld it up tight. And then, if future human civilizations come up to this giant building, they will find a steel canister that is very hard to get into. And hopefully they won't try until they learn what radiation is. But maybe there's a problem. So let's say that's not a good situation. We want to defuel all of the nuclear plants because the world is ending. So the next thing is that you go through the defueling process. You take all of the fuel out, you put it in the cooling ponds. You take all of the fuel that's been in the cooling ponds for a few months and put it in dry casks. Okay. And those dry casks, they sit like monoliths. They're nearly impenetrable monoliths of concrete and steel.
Damn, where's the 2001 A Space Odyssey monolith sound when I want one?
So this is sort of the realistic scenario that if the world is ending and we really have to put that stuff away, we can at least get it all into dry casks in, let's say, 6 months. All of it will be in dry casks and it will all be air cooled. And hopefully no one's going to be dumb enough to throw some chemical explosives at it.
But see, people are dumb enough, Carl. People are dumb enough. They're vicious enough, stupid enough, ignorant enough. I don't put anything over on some extremist nutbag. What happens? Tell us what happens.
Yeah, if they crack open a dry cask, you'll get a little dusting of spent fuel. Sort of like the dusting that I might have gotten in May of 2019. And that's really the worst that could happen. I mean, this is the worst that could happen is a very minor local contamination. That's the worst that I think would happen.
This is heavy. Minor. I'm going, I'll listen to this twice after we do it because when you run the show, you still have to listen. All right, Tim.
Right.
Tim, my favorite not my favorite. One of my many favorites, Tim. Environmental Coffee House. How familiar is Karl with Jevon? Jevon's paradox, Jevon?
Jevon's paradox. When South Korea got the LED light bulb, we thought they would reduce their energy consumption. They, in fact, increased it a bit because they wanted lights everywhere. This is Jevon's paradox, is the more efficient you make something, you don't necessarily reduce the resource consumption. People who get more money, they don't save for the future. They improve their lifestyle.
Right.
That's Jevon's paradox.
Then what do we do if nuclear becomes fusion or what do you do? How do you prevent that? Because it's just going to keep going. Consumerism.
Hopefully, what we have today with consumerism is fossil fuel driven consumerism. So I think that we should slow down consumerism. I agree in the 1 kilowatt lifestyle. We should reduce our consumption. We shouldn't fly as much. I ride an electric bicycle. You know how hard it is to actually have a job and ride an electric bicycle? I do it. I have literally 2 electric bikes in my garage right now. One that's a class 2 that I can ride anywhere legally, and one that it's a class 3 plus and I can get away with it every once in a while. Now that's the one that I ride on the street so the cars don't kill me. And I avoid consuming. And I think that a lot of people do and want to. And I think we need to work collectively to change our modes of transportation, consumption, have right to repair, have all these societal advancements that will reduce our consumption intentionally. And I think it's something that the international community is ready to do. So I hope to see you at COP28 in United Arab Emirates, and we can talk about this.
COP28, COP26, COP15, COP. All right. What else? Jean, I think I did this already. Bila, 400,000 tons of over 1,000 radioisotopes have been created in the world's nuclear plants. None of that has been secured. Or has it?
What do you mean secured? Because
is it in casks? Is it all in casks somewhere like where I live at West Valley?
At least 40% of it is in casks, and the rest of it is behind a security barrier at a nuclear facility. So it's mostly secured, if not completely secured. Maybe someone at any of those nuclear sites goes a little nuts, and what would they jump into the pool? Would they try to lift it with a crane? There's 290 other people at each of those facilities that would stop them from doing anything.
And Nicholas Miller, one of the greatest problems is all of the billions of people in the so-called developing countries that are chomping at the bit to consume more and more and more because they see what we do. And that is a huge problem, and it's beyond the scope of the discussion here. But but I love it. I think that people all around the world deserve to live a better life. I think less of them,
like
it, especially in the United States too. Just less of them.
I think that U.S. we need to come down from 2 kilowatt to 1 kilowatt, and at the same time we can take everyone who's here dying and starving at 200 watts and bring them up to 600, 800. And this is where I know that we're doomers here and we're worried about population, but population is very closely related to energy consumption. The less energy you have, the more you depend on physical labor, and the more you depend on your immediate family to survive in your old age. Think about that. You have energy, Sandy. you can survive easier because you have energy to replace human labor in your home. You don't need to have someone cutting firewood for you.
Oh, yes, I do. What, are you kidding?
Oh,
I'm disabled as hell. Oh no, I have to.
no.
I have people cutting,
But
doing, lifting, bringing. I pay
Mhm.
people to help me do everything. I'm supremely disabled.
Oh,
But
but you also have access to other methods of heating your home, right?
yes, but I don't like to use them. I use electric
Okay.
heaters.
Yeah, and those electric heaters will keep you alive, right?
Yes.
So,
All right, listen, I
so
have.
you're using energy
Yes,
to
of
survive.
course I'm using energy to survive. Everybody is. All right, now Giant Curve, you were not here in the beginning. The question, if you are pro-nuke, why is the video title entirely negative? And I'm going to explain my part here. I am neither pro nor con for this show. I have a guest who has a position, okay? I'm not giving what I think here because that's not my role. My role is to interview the guest. It's not about me. So tell him, Karl, why the title was done. Reiterate that.
So what we found is the Biden administration and our government has been really overhyping the fusion advancement that we had this week. Sure, it is really encouraging to have a net thermal increase in efficiency that's over like the required break-even point. We are better than break-even for just the thermal part of the fusion reaction. That does not mean that a fusion reactor is 10 years away. And in fact, when you look at the funding for the National Ignition Facility, when you look at the projects that it's supporting, it is directly supporting the maintenance of our nuclear weapons stockpile. And that's what I'm here to talk about, because so few people in the press have made this front and center. They've all put it below the fold or completely ignored the fact that this is a physics advancement that it's purely going to be applied to the weapons industry. And that's disappointing.
Okay. All right. Let us go. I think Paul Mobley is going to be the person. He's going to write to me, Paul, at environmentalcoffeehouse@gmail. You're compelling and interesting. Why is there nearly a nearly 60% increase in cancers around Vogely, Georgia, with what is it? 94.1% decrease in, oh shit, I lost it. And Georgia, there must be something there. Do you know what's there, Paul?
I'll need to look at the papers. I know
Okay.
that Vogel, we have 2 nuclear reactors there. However, is it an industrial area? Is it?
Maybe
Are
I
people
don't know.
there exposed to chemical contamination? Are people who live there getting free healthcare now? These are all the questions, and in
Yeah.
fact, these are all things that relate to the kick study explanation. And so we need to control, because we're scientists, we need to control for different effects before we blame the thing that we hate.
There's a lot of things. A lot of things. All right. We already did. I asked the Bill Gates reactor question, right? I have to get rid of that. Okay. Boy, guys, you've got a lot of. There's a lot of conversation coming out here, and I do really appreciate it. We are 1 hour and 58 minutes. Wow. Holy moly. This went fast. This went really fast. It just did. I'm not like my back. Tom, I use wait, did I hear Sandy say she uses electrocutors Yeah, electric heaters. Yeah, I do. I do in my room and in here in the office because I don't like propane. I'm not going to. All right. So since we're pretty close to the end, I'm going to see if I can pick a couple of gotchas. And then we're going to work on we're going to do the pro and con with me just mediating and not, I'm obviously not an expert here at all. OG Skywatch, I saw a video on the laser fusion. It said that this type of fusion by laser will be used for weapons, and we talked about that. So we know that's what Karl was saying. It's going to be used for weapons long before it will ever be used for clean, cheap energy. And this is Karl's position. Yeah. Okay. Karl's a progressive. I guess, but not all progressives are anti-nuclear energy, so there you go. And I know. All right, let's see. Oh, here's Morning. Hi, Morning. What about the radiated milk in California from Fukushima?
That would have had to come from radioiodine. And by the time that contamination came across the Pacific Ocean, it would be extremely, extremely small. It would have degraded. Let me bring up my isotope browser. I have an app here where I have a list of all the isotopes. It's the IAEA isotope browser. So I'm going to put in I131 go. And that gives me a half-life of 8 days. So this is what you're talking about with the contaminated milk. This is what caused that thyroid cancer in Chernobyl. And so I would need to see a little bit more evidence that any iodine 131 was detectable, or even at significant levels in California, and that would only happen immediately after the accident. And so it would be extremely doubtful that anyone would have an exposure at that time. It would be extremely difficult to see anyone in California having an iodine 131 exposure from Fukushima Daiichi. I think it took something like 4 years to see cesium elevations rise outside Alaska. And that's twice as close as California is.
All right. Well, the only thing I know, Nicholas had said this is a surprise. The Lawrence Livermore Lab is a government-sponsored weapons research. I mean, that's what they do. So we know. All right. Well, everybody. Karl, did you want to give a closing statement? Do you need to do a closing statement? Oh boy.
Well, no, thank you so much for having me on the program. I do have hope. I had no hope, especially after 2016. I had almost no hope, and I think that the application of technology is going to give us the best hope possible. It may not be that if we had a revolution to destroy capitalism, that might not ever happen in our lifetime. We could try, we could hope and wish for it,
right.
But I think it's more likely that we're going to have advancements in technology that will be just enough to keep us here on this planet so that we can eventually win in the long term. And that's really my final hope, is that we need to keep all of this going just so that we can have a better life. And if you don't think so, well, you're going to have to buy a farm. You're going to have to escape. You're going to have to, you're going to have to do what you can to survive, because we need to survive as a human race. We need you. So no matter how you address this climate crisis, I trust that you're doing the right thing. You're working to at least save your family, and at best save the rest of us as well.
Okay, well, wait a minute, Giant Curve. Who said I'm against hope? We say hopium, but, I do hold out little shreds of hope because I'm a mom and I have a 34-year-old daughter and I care about her and I care about my friends' kids. So, part of me says, wouldn't it be nice? But but do I hold out hope like anything's going to change in the big thing? Well, look at my hat. But again, I don't, I have a kid. So there's the answer for me. I don't want to see her perish because of the stupidity of the fossil fuel industries and the stupidity of, singing ways here. Stopping the use of fossil fuels lays a foundation for future scientists to have a civilizational structure to support innovation. But I don't know if she realizes that you are saying let's stop it by using nuclear. So she's going to have to go back and watch. She definitely is. And no, see, people are putting words in my mouth. Not on this channel. According to EC, the population needs to be wiped out. No, I've never said it. I've never said it. Jennifer has never said that. This is the wrong channel. Lisa, I've never said that. Okay? So don't put words in my mouth, please, because I've never said it. I believe in birth control. I believe in teaching people in different countries that they don't have to follow a dogma that's being shoved down their throat. I'm pro-woman. I mean, geez. So don't put words in my throat. Thank you. Thank you. Thank you. All right, guys. It is long show. Great show. We really did appreciate you. Thank you for stopping in. I think if Paul Mobley would like to email me at environmentalcoffeehouse@gmail.com, it would be great. And maybe we'll set something up. Karl, what do you think?
Yes, absolutely.
But he says you have to look a little bit different and not look like you're reading stuff. Even though I don't think you're reading stuff.
I am reading chat. That's what I'm reading.
Yeah, that's okay.
But you know what? I think that it's fair. It's fair to refer to the sources that you have gathered over the years. I'm not bringing up new sources. I'm going back on things that I have learned years and years ago. I've been at this since about 2015, 2016. So I welcome, with no restrictions, bring me whatever information you have.
All right. All right, everybody. Kim, thank you for moderating. Everybody, thank you. Nicholas, it was great to have you. Veg, Paul Mobley, thank you. Jean, I love you. Earl, great. It just Blocksworth, Snout, who said it? Who said that? Everybody, Jay Brandt, Bila, everybody, thank you so much. Bim Jim, Tony, there's a lot. But the truth, thank you for being my supporter for the thumbs up. And we literally have 55 thumbs up and 5 thumbs down. Oh, maybe I really will get recognized by the algorithm, even though I'm not monetized, so they don't really give a shit about us. And Donald keeps telling me to put on the things, but it's hard to. I can't monetize Doom, Donald. I've told you that 100 million times. It's very hard, but I love you. But I do have Buy Me a Coffee, and they all know it. So thank you, Karl. We are out of here. We are gone. Thank you. I love you guys. And I'm not on Tuesday night. Bim Jim, it has not. It has not been a paid advertisement for the nuclear industry.
Where's my check? I want my check.
God, can't I just bring on somebody I've known for a while? Silly. Stop it.
I have a closing. I like to close my program with, and I missed my chance because my internet crashed. So I'll say,
okay.
Our mission comes first. Peace and justice will follow.
There you go. Beautiful. I love you guys. I'm only teasing most of you. You know that. You know that. Whatever. Heart. Big heart. Big heart. I have a big heart.
Nice. Okay, I really got to run. Thank
All right,
you.
run.
See ya.
Bye, sweetheart. Gene.